This video will be covering numbers 13 through 24 from the January 2020 Geometry Regents exam. In 13, we're given circle B below, diameter RT, radius BE, and chord RE are drawn. If the measure of angle TRE is 15 and BE is 9, then the area of sector EBR is. So we're going to be figuring out the measure of, or the area of this sector here, EBR. One thing the Regents has really been doing on a lot of questions is giving you a measure of an inscribed angle. But the area of a sector formula is central angle over 360 pi r squared. So I need to figure out what this central angle over here is in order to find the area of that sector. Well, since it's an inscribed angle of 15, it is half the measure of the intercepted arc. If that's confusing in this picture, think about it just like this in a simpler form. If that's 15, the arc is 30. And since this is a central angle, angle TBE, that is equal to the arc. And then we have two supplementary angles here, so that makes this 150. So I have 150 as the central angle of that sector over 360. The radius is 9 of this circle, and we're looking for our answer in terms of pi. I know that because all the answer choices have pi in them. So I'm not going to type pi into the calculator. I can type everything else. And I get 33.75, which makes this choice 3. 14, Lou has a solid clay brick in the shape of a rectangular prism, the length of 8 inches, a width of 3.5 inches, and a height of 2.25 inches. If the clay weighs 1.055 ounces per inches cubed, how much does Lou's brick weigh to the nearest ounce? Okay, so if I take a look at this here, I definitely want to figure out the volume. So volume is area of the base times the height. But a lot of people can just think about volume of a prism, rectangular prism anyway, as length times width times height. So I'm going to do that here. So I have 8 times 3.5 times 2.25. So the volume of one clay brick is 65. And I'm looking for the mass. So I'm going to use the density formula. This unit is density because it's a mass unit over a volume unit. So the density is 1.055. The mass is what we're looking for, and we knew the volume is 63. If I cross multiply this here, I get 66.465, and to the nearest ounce, that's choice 1, 66. All right, taking a look at number 15, rhombus ABCD can be mapped onto rhombus KLMN by a rotation about point P as shown below. What is the measure of angle KNM? I'm just going to put a question mark in there since that's what we're looking for. If the measure of angle CAD is 35. Okay, so let's think about what matches up with one another. So CAD, if we were trying to figure out what angles correspond from one picture to the other, here's how I'm going to map it. So C and M should correspond. So CAD is equivalent to angle M. I'm going to finish that angle, by the way. So A and K correspond, so MK. And then D and N correspond. So when we have a rotation, angle measure is preserved. So if CAD is 35, I now know angle MKN is also going to be 35. In a rhombus, the diagonals bisect the angles, so I know there's a 35 over here as well. And total, that gives me 70 degrees. When we're taking a look at this here, if I look at the angle we're trying to find, it's supplementary to 70, and so it's 110. Here's a hint for this problem. If we assume that this picture is drawn to scale, angle K and M, the angle we're looking for, definitely looks obtuse, and there's only one answer choice with an obtuse angle. 16, in right triangle RST below, altitude SV is drawn. RV is 4.1, TV is 10.2. We're looking for the length of ST. All right, I'm just going to add this up to get the whole hypotenuse on the bottom. And I know it's a hypotenuse because it tells me we have triangle RST. So this is 14.3 as my total hypotenuse. And for these problems, I use the Hills and SAS shortcut. So Hills means use the hypotenuse of the big triangle over the leg of the big triangle, and whatever segment is closest to it. So I'm going to cross multiply here. So I have 14.3 times 10.2. And I'm going to take the square root of that. And I get 12.077, and to the nearest tenth, that is choice for 12.1. 17, on the set of axes below, pentagon ABCDE is congruent to the same one with double primes, which describes a sequence of rigid motions that maps the pre-image basically onto the final image. So we have a few ways we could do this. What might help is to look at some coordinates here. So if I want, I'm just going to write down a couple here. So I see that A is 2, 2, and B is 2, 5. You can list all 5 coordinates. I'm just going to start with 2, and I see that A double prime is -2, -5. And B double prime is -5, -5. So automatically I notice something here that I think there's going to be some sort of translation that's involved in this. And also possibly a rotation, because I can see that it's been turned on its side. So if I imagine this pentagon, so I'm going to just trace over that. If I imagine that basically turned 90 degrees, okay, assuming this is congruent, I can see that it would basically face the same way here. So I'm going to start by guessing a rotation of 90 degrees. And if I do that to the original points, and this would be counterclockwise about the origin, by the way, the rule is negate y, then switch. So that would give me -2, 2 for A prime. For B prime, negate y, then switch. That would give me -5, 2. So now I have to think about if I have -2, 2 as A prime and -5, 2 as B prime. And again, I could find all of the other points too, but now you guys can see that they're in line with one another, and I just have to do a translation, and that's going to be a translation down 7 units, and this is going to give me choice 2. So if you're not good at visualizing these, because I do think that these can be hard to visualize, if you know your coordinate rules, you could try that and work through your answer choices. This can be a time-consuming question, but keep in mind you're not in a rush when you take the Regents exam. You have up to 3 hours. So this is one you can certainly sit through and spend more time on. 18, on the set of axes below, rhombus ABCD has these vertices. What is the area of that rhombus? So what I'm going to do, I do every area on the coordinate plane problem the same way. So I'm going to draw a box around the given shape. This is what I call the box it in method. And basically what I'm going to do here is I'm going to find, so let's color this in a little bit so we can see. I'm going to find the area of the box. I'm going to find the area of these surrounding triangles that I'm highlighting in pink here. And I'm going to subtract them. So the area of the box, this is 6 going across, going up it's 8. So the area of the box or the rectangle is 6 times 8, or 48. Let's number the triangles just to keep them consistent here and organized. So the area of triangle 1 is 1/2, 3 times 4, or 6. You might notice in this picture that all 4 of those triangles look the same, and they are. They all have, if I calculate them, an area of 6. And now we can subtract them. So I have 48 minus 6 minus 6 minus 6 minus 6. And I get 24 as my area of the rhombus. So choice 2. 19. Which figure or figures can have a triangle as a 2-dimensional cross-section? So cross-section is basically the shape that you get when you can like slice the object. So choice 1, a cone, definitely can give us a triangle because if we think about what it looks like from the front, it has a triangular shape. A cylinder doesn't have anything triangular about it though, so I don't think choice 2 is going to work, or Roman numeral 2, I should say. A cube might be misleading. You might think, oh, I can get squares. But if you imagine a cube, right, and I try and just draw one here. Imagine that you just took like a knife and you just sliced off the corner. You're going to get this little triangular shape there. So I can get a triangle for the cube. And then a square pyramid. Pyramids have triangular sides, so I definitely can get a triangle there. So Roman numeral 1, 3, and 4 would work. And that gives us choice 4. For number 20, what is an equation of a circle whose center is 2, -4 and is tangent to the line x equals -2? Well, let's start with the center part. When you're finding the area of the equation of a circle, you're going to take the opposite of these values. So I'm looking for a -2 and a +4, and that's choices 1 and 2. So I'm going to cross off 3 and 4. Let's talk about the tangent part though. So I'm going to draw a quick set of axes here. The point 2, -4 is our center. And it's tangent to the line x equals -2. So that is a vertical line at 2. And if it's tangent, that means the circle is just touching that line. So if I look at where it crosses that line to the center, that's our radius, and that gives me 4 as the radius. Putting that in the equation would give me 16, since the formula for center radius form of a circle has radius squared at the end. If this graph is confusing to you, remember that you do have scrap graph paper in the back of your Regents exam booklet, so you could always plot more accurately if needed. 21, for the acute angles in a triangle, the sine of 4x is equal to the cosine of 3x plus 13. What is the number of degrees in the smaller angle? So the sine of an angle is equal to the cosine of its complement, which means these two angles have to add up to 90. So if I solve here, subtract the 13 over, I have 7x is 77, x is 11. But I want to plug back in to get the angle measure. So if I plug 11 back in here, 4 times 11 is 44. If I plug 11 in here, I'm going to get 46. So the smaller angle is choice 3, 44. 22. Triangle PQR is shown on the set of axes below. Which quadrant will contain point R double prime, the image of R, after a 90 degrees clockwise rotation centered at 0, 0, followed by a reflection over the x-axis? This reminds me of the question we saw before. It was 17, where you could work with this graphically, or if you are good at memorizing rules, you can memorize your shortcut rules. So let's make up a point for R. I don't have actual coordinates here, but let's say that maybe R looks like 5, 3, if I had to give it coordinates, something around there. So if I do a 90 degrees clockwise rotation, that is the same as 270 counterclockwise. So 5, 3, I would negate the x and switch. And then reflection over the x-axis would negate the y value. So I'd get 3, 5. If I plot 3, 5 approximately, it's going to land in that same quadrant, quadrant 1. As a reminder, this is quadrant 1. And then we go in a counterclockwise circle, 2, 3, and 4. 23, in the diagram below of right triangle ABC, altitude BD is drawn. Which ratio is always equivalent to the cosine of A? Well, cosine is always adjacent over the hypotenuse. So if I look at A, the adjacent is AD, and I'm looking at this triangle, for instance, ABD, over the hypotenuse AB. That is a perfectly correct answer. It's just not one of the answer choices. So I have to find another way to basically come up with the answer to this question, and that's going to be through utilizing similar triangles. Okay. So if I am going to use similar triangles, I'm going to actually draw these triangles separate for a second. So again, I just have to do this because my answer that I came up with is just not an answer choice, so there must be something else. And I'm going to take this other triangle here that I'm highlighting in blue, and I'm just going to rotate it so that it looks like it's facing the same way. So that would make this BDC. So you'll notice here that A and B correspond to one another, which means they're congruent because we do have similar triangles. So if I find the cosine of B, the adjacent side is BD, the hypotenuse is BC. That is an answer choice, and we are going to get choice 2. So if your immediate answer doesn't work out, try and basically find an equivalent angle. All right, our last multiple choice question, 24. In the diagram below of triangle RST, L is a point on RS, M is on RT, LM and ST are parallel. RL is 2, LS is 6, LM is 4, and ST is x plus 2. We want to know what is the length of ST. So one thing that I'm going to do here, similar to how I drew the triangles separately in the previous problem, I'm going to do the same thing. So I'm going to draw this small triangle RLM that has sides 2 and 4. And I'm going to draw the big triangle. This is x plus 2, but now we can hopefully see that this base is actually 8. It's not 6 because that's not the side of the triangle. And now I can set up a proportion to solve. So 2 matches up with 8, corresponds with 8. 4 matches up or corresponds with x plus 2. And let's cross multiply. 2x plus 4 is equal to 32. Subtract the 4. 2x is 28. X is 14. We're looking for the length of ST though, so when I plug in, I'm going to get choice 4, which is 16. You can head to the next video in this playlist to see the answers to the part 2 questions from this Regents exam.